right, good morning or afternoon or whatever it is for you today. Today we are doing a lesson on the Argand diagram and complex numbers. So first let's talk about the real numbers. The set of real numbers. These are the numbers that we're all familiar with. 1, 2, pi, a million. This is the ordinary set of numbers that we deal with on a daily basis, count real-world objects with real-world problems. However, there's another set of numbers, the imaginary numbers, and these actually have a lot of real-world applications. So the imaginary number, which is I, we write it like this, is said to be the answer to the square root of -1. So as you may recall, if you square a negative number, you get a positive. If you square a positive number, you get a positive. So in order to get a square root for a negative, we have this lovely thing known as I, the imaginary number. And that means that there's a second number system, basically, alongside the real numbers. We have the imaginary numbers. So I have I, I've got 2i, I've got -pi, and everything else I could possibly want. So this set of numbers, which is always going to have an I after it, these are imaginary. But if we combine a real number, this is real, and an imaginary number, we get what's known as the complex numbers. Complex numbers. So something like 2 plus I is a complex number. There's no real way to combine or simplify this expression anymore. We have the real part over here, the 2, this is the real part, and the I is the imaginary part. To generalize this, we have a plus bi. So any complex number is going to look like this. We have some real number, a, plus some real number b times I. So this is the imaginary part, and this is the real part. The question becomes, how do we think of this graphically? And that's where the Argand diagram, also known as the complex plane, comes in handy. So let's draw some coordinate axes, and let's make this real numbers. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? Pretty simple. But our second axis, this is our imaginary axis. So all of these numbers are going to be something times I. So I, 2i, 3i, 4i, 5i, right? This is 5i. Down here, -1, -2, -3, -4, -5. This is -5i. So this plot that we've created here, this coordinate plane, basically is the Argand diagram. Argand diagram. It's an A. So let's say we want to use this diagram. We want to plot a number. So we go back here. We have 2 plus I, right? 2 plus I. So first we're going to go on the real axis, 1, 2 right here, and then I is going to be up 1. So this right here is the number 2 plus I. And so it's pretty much this pretty easy system where instead of having in the normal coordinate plane, the Cartesian plane, you'd have 2, 1, where one component in this ordered pair would represent the x and the other would represent the y. Here we have a sum, and one component is real and one component is imaginary. So I could say -3 minus 2i. I would count over 3, 1, 2, 3, and count over -2, and that would give me this point. This point is -3 minus 2i. So that's basically the system of the Argand diagram, and it actually allows us to do a whole lot of useful things. It makes imaginary numbers incredibly useful, And we can describe these imaginary numbers then using a couple different properties. So we've given here our component form, right? Components. But there are several different forms I could make as well. If we look here, right, we've got this triangle, so you can describe it with some sort of angle and a magnitude right here. This distance, I'm going to label it C. It's basically the magnitude of the triangle. You could do this with normal coordinates. But this magnitude right here is special. This is the magnitude of some number. And we can find this using Pythagorean theorem, distance formula. But this is essentially the absolute value of a complex number because it's the distance it is away from the origin, which is 0, right? So we get a whole lot of cool applications out of the Argand diagram, and stuff like this is related to that. All sorts of excellent things extended for more use of complex numbers, which is a whole field of mathematical study. So that's pretty much all I have. Thank you guys for watching. I hope you learned something. If you have any questions or you want to see content on anything else, please let me know. Have a great day, and I'll see you in my next video.